Good afternoon, student. How are you? I hope you are with your family at your home with good health. So now, some student have problem in chapter second. Some question are here 10, 13, 18, 19, 21. Two, three question I will also express you. Our first question is tangent inverse 3a square x minus x cube upon a cube minus 3ax square. So write it in simplest form. Question is write it in simplest form. Do you know simplest form? We will make it the formula of a tangent theta. So you know tangent theta near about tangent 3 theta. If you will see the given expression in the form of tangent 3 theta, when we will divide numerator and denominator by a cube. Divide numerator and denominator by a cube. 3a square x upon a cube minus x cube upon a cube upon a cube minus 3x square upon a cube. Now tangent inverse, you can see a square with cancel a cube, then we have x upon a minus x upon a whole cube, a cube cancel 1 and 3x by a whole square. Okay, now if we will put x by a as tangent theta, then tangent inverse 3 tangent theta minus tangent cube theta by 1 minus 3 tangent square theta. You will see it is the property of tangent 3 theta. So now tangent inverse into tangent 3 theta. Tan inverse tan will cancel. The answer is 3 theta. And the value of theta is we have put here x by tangent theta. Then value of theta is tangent transpose is tangent inverse. Okay, so now our answer is 3 tan inverse x by a. It is the simplest form of tan inverse 3a square x minus x cube minus 1a cube minus 3ax square. I hope all are doing well. If you have problem, you can send me WhatsApp also. Next question number 13. Tangent into sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. So in this question, for simplest form, you will put x as tangent A and y as tangent B. Now tangent, question number 13, sine inverse 2 tangent A upon 1 plus tangent square A 1 minus tangent square B upon 1 plus tangent square B. Now you know property of 2 tangent A by 1 plus tangent square A is, yes we did, it is the property of sine 2A, and similarly property of cos 2B. Now sine cancel, cos to cos cancel. Now we have 2a plus 2b. I think here half also is there. Yes, 1 by 2 is also here. 1 by 2, 1 by 2. Now 2 is common and cancel with 1 by 2. The resultant is tangent A plus B. Or you know, value of tangent A plus B is tangent A plus tangent B 1 minus tangent A tangent B. What is tangent A here? X. Tangent B y upon 1 minus xy. Now it is the simplest form of tangent half sine inverse 2x upon 1 plus x square and cos inverse 1 minus y square upon 1 plus y square. Question 10, 13, now 18. Question number 18. Tangent into sine inverse 3 by 5 plus cot inverse 3 by 2. You know, we have property tan inverse x plus tan inverse y, that is tan inverse x plus y upon 1 minus xy. We will change sine also in tangent, cot also. You know, sine inverse is 3 by 5. So we can change directly. You know, sine theta is perpendicular by hypotenuse. So by Pythagoras it is 4. So we can change sine into tangent. Okay. So on the behalf of this value we will write tan inverse. Tan theta is perpendicular by base. Or we have done a property cot inverse theta. The cot inverse x is tangent inverse 1 by x. So cot inverse 3 by 2 is tangent inverse 2 by 3. Now you can apply tan inverse x plus tan inverse y. That is tan inverse x plus y upon 1 minus xy. Tan cancels. Now you will solve 3 by 4 plus 2 by 3, 1 minus 1 by 2. You can solve taking LCM and find the value. Okay, next is (18). 18 we have done. Then 18, after 18, 19 and 21. 19 is cos inverse cos 7 pi by 6. So you know, cos inverse into cos x is equal to x when x belongs to 0 to pi. So here 7 pi by 6 not belongs to 0 to pi. So we will change it into cos 7 pi by 6 written as pi plus pi by 6. You know, cos pi plus theta. Cos pi plus theta is minus cos theta. Or you know, cos inverse minus theta is pi minus cos inverse theta. So we will write pi minus cos inverse cos pi by 6. Cos to cos cancel. Pi minus pi by 6. 6 is LCM. Then we have 5 pi by 6. After 19, question number 21. Tangent inverse under root 3 minus cot inverse minus under root 3. So you know tan inverse under root 3 cot inverse minus theta. Cot inverse minus x written as pi minus cot inverse x. So pi minus cot inverse under root 3 minus pi minus minus plus. Now we can write combined tan inverse under root 3 plus cot inverse under root 3 minus pi. Next we have another property, tan inverse x plus cot inverse x is pi by 2. We both have same values, positive also. So we can write tan inverse under root 3 plus cot inverse under root 3 as pi by 2 minus pi. Taking 2 as LCM, pi minus 2 pi is minus pi by 2. Question number 21. Now some another problem. Solve the following equations. Question is 2 tan inverse cos x. Everything miscellaneous. Question number 13. Question number 13. 2 tan inverse cos x equal to tangent inverse 2 cosecant x. We will find the value of x. So you keep in mind what is the property of 2 tan inverse theta. Here 2 tan inverse x, that is tan inverse 2x upon 1 minus x square. So we will follow here this property, tan inverse 2 cos x upon 1 minus cos square x. Here tan inverse 2 cosecant x can be written as 1 by sin x, because here not inverse, only cosecant. Now tan inverse cancel. 2 cos x 1 minus cos square x sin square x, 2 by sin x, 2 cancel, 1 sin cancel, cos by sin cot x, that is 1. Where is 1? You know cot pi by 4 is 1. Cot cancel, then value of x is pi by 4. Another question. Miscellaneous 16 question, important question. Sin inverse 1 minus x minus 2 sin inverse x is equal to pi by 2. In this question, you should keep in mind one pattern for make it easy. I will put sin inverse 1 minus x as A and sin inverse x as B. If sin inverse transpose in right side, we know that is sin A and x is sin B. Okay, so we will write here A minus 2 times here B equal to pi by 2. Minus 2b in right side plus 2b. Okay, taking sine both sides, sine A sine pi by 2 plus 2b. So you know sine pi by 2 plus theta, cos theta. Or you also know cos 2 theta is 1 minus 2 sine square theta. Now, what is value of sine A? 1 minus x. Sine B, x, then x square. Transpose into left side, then 2x square is positive, and here 1 minus 1 You know 2x square minus x is 0, x is common. So either x 0, either x is half. Now 0 or half, you will select it. Which value will satisfy in this question? Okay. Next problem. Tan inverse cos x upon 1 minus sin x in simplest form. So we have already discussed simple cos change into sine. We will write it sine pi by 2 minus x. And along with one cos should be there. Sine x change into cos pi by 2 minus x. You know sine theta written as 2 sine theta by 2 cos theta by 2 and 1 minus cos theta 2 sine square theta by 2 cancel. Now cos by sine is cot pi by 4 minus x by 2. Now we cannot cancel because here tan inverse, here cot. So cot theta can be written as tangent pi by 2 minus theta. Minus minus plus. Now tan inverse cancel. Pi by 2 minus pi by 4. Pi by 4 plus x by 2. Which is the simplest form of tan inverse cos x upon 1 minus sin x. So in NCRT, I think no any problem, you can solve it. One question is question number 9. Tan inverse under root x miscellaneous half of cos inverse 1 minus x 1 plus x. X belongs to 0 to 1. So you will see, let pause करना बेटा for RHS. X is tangent square theta. Then half cos inverse 1 minus tan square theta 1 plus tan square theta. 1 minus tan square theta 1 plus tan square theta is the property of cos 2 theta. Now cos to cos cancel, 2 to 2 cancel, we have theta and value of theta from here square convert into square root and tangent transpose is tangent inverse. Okay, now in left side we have also tangent inverse under root x, that is left equal to right. And question is cos inverse 12 by 13 plus sine inverse 3 by 5 equal to sine inverse 56 by 65. Left side cos inverse 12 by 13 sine inverse 3 by 5. So you know we have property only tan inverse x plus tan inverse y, that is easy. Other two property also, cos inverse x plus cos inverse y, sin inverse x plus sin inverse y, but we will follow heavily here tan inverse x plus tan inverse y. So in this question we will change cos and sine into tangent. Cos is base by hypotenuse. Then by Pythagoras it is 5. Sine is perpendicular by hypotenuse, then Pythagoras is 4. Cos change into tangent, tan inverse perpendicular by base. Same here, perpendicular by base. So now tan inverse x plus tan inverse y. So that is tan inverse x plus y upon 1 minus xy. You will solve it. The resultant is 12 as LCM. 4 3 3 is 9. 5 by 16. 16 minus 5 by 16. We have tan inverse 14 by 12, 16 by 11. 4 3 is 12, 4 4 16. An approximation tangent inverse is given 56 by 33. Make a triangle. Tangent is perpendicular by base. So by Pythagoras it is 65. Convert into sine. Then sine is perpendicular by hypotenuse equal to RHS. Okay. If you have any another problem, you can ask me on WhatsApp number. Then I will solve and will send a pic of that solution. Okay. Then today you should complete it. And tomorrow we will start another chapter. Thank you. Stay home. Stay safe.